Today we'll be talking about Cloud BigTable. What is a Cloud BigTable? It is a fully managed, scalable, NoSQL database service for large analytical and operational workloads. I'll explain this further. One is, it is a live database, which means it uses real-time processing to handle workloads whose state is constantly changing. Next is, it can handle terabytes and petabytes of data with very low latency. So this is more suitable for applications that are highly scalable, where you can do reads and writes at a very large scale. Next important point is it is on a NoSQL architecture. So you cannot write your queries on BigTable. Next point is it deals with semi-structured data. It means it has attributes like structured data, but the set of attributes can vary from one instance to another. The last point is it is not relational database. So it stores data in a non-tabular form and tends to be more flexible than the traditional database structures. So who uses Cloud database? Cloud BigTable. Google Maps, Google Search, Google Book Search, YouTube, Gmail, to name a few. If you notice, these applications are highly scalable. They require terabytes and petabytes of data with very low latency. So for this reason, BigTable is used in the backend of all these apps. What are the benefits of Cloud BigTable? One is speed. Next is maintenance and scale. So now maybe you're developing an app which is innovative and it has huge potential. So if it's as successful as you expect, you may one day exceed the limit of traditional systems. So that's where Google Cloud BigTable comes into play. Here, what I need is NoSQL database that is fast, simple to maintain, and scales from gigabytes to petabytes with no downtime. Google BigTable is fully managed service. This is one more plus point. This means you can concentrate on your app instead of tuning your database. With its unique combination of low latency and high throughput, Cloud BigTable can scale to reliably handle massive workloads at lightning fast speed with no reconfiguration downtime. Now, Cloud BigTable is compatible with industry standard tools like HBase, Hadoop, and Google BigQuery and Cloud Dataflow. This means it's easy to put all that data to work for your app. So this is just the overview of Cloud BigTable. We'll learn more about it in future sessions. Now, I'll take you through a hands-on on Cloud Console. Today, we're going to create a BigTable instance, and we're going to use a command line utility to connect a BigTable instance, read and write data in a table, and finally, we'll clean up so that we don't incur any cost. Now, what is a BigTable instance? It's just a container for your data. Now, instances have one or more clusters, and they are located in different zones. So it means it can't be in the same zone. And each cluster has at least one node. See, now the node is where data is stored. Now, when your application sends requests to a Cloud BigTable instance, those requests are handled by one of the clusters in the instance. I can show you what these are on Cloud Console. I'll move to Cloud Console. Here, before I create an instance, I have to select my project. It's selected here. I go to the navigation menu and I'm going to enable my APIs. I'm going to go to the library. I'm going to just search. See, here I have 3 APIs to connect. I'll enable them. I'll check if it's enabled. Yes, it is enabled here. Now, if it's not enabled, it's just a click. I just have to enable it there. I'll check the other one. It is. And the third one. So it is enabled. Okay. Now I move on to the navigation menu. I'll go to BigTable. It's under the databases. Yeah. Here I create the instance. So this is where the data is stored. I give it a name. MLGC01 and I continue. Here you have 2 storage types. HDD is, it performs better than SSD. I'm just going to continue with SSD. Here, this is the cluster, what I was talking about. So now every instant can have 1 or more clusters. Okay, and the cluster can, every cluster should be in different zones. See here, I select the zone. I'm going to select Virginia, which is closer to me. I'm going to select a zone. So like this, I can add more clusters. I'm just going to stick to 1 and I'm going to leave with 1 node and create my instance. Yep, the instance is created. Now I'll go to Cloud Shell. Here I'm going to add the tables and also add data into the table. I'm just going to bring this up. Yeah, so now I'm going to configure the Cloud BigTable to my project and instance by creating a file. I have copied few commands here. So I'm going to give it a name. I connect the project and also the instance. Yeah, this is my project ID, which is connected to the BigTable now. And this is my instance, which I created. Now I'll verify if it is set up correctly. So this is the command. Yep, you see it's there. Now next is I'm going to create tables. I'm going to create 1 table which contains row. So this is the command cbt create table my table. I'm just giving it a name as my table. The table name is my table. I authorize here. I'm going to see if my table is created. cbt, I'm going to list it. You can see the table is created here. Okay, now we're going to add one column family. Now I have a table which has rows. I'm going to add one column family. I'll name a family, say CF1. So that's the command. I'm creating a column in this table with name CF1. Now I can check if that's created. So that's created. So I've created a column in the table. Now I'm going to fill data into it. So I'll just put a value, say test value. So the command goes like this, cbt, I add a value in the table in row 1 and in the column family CF1 in the column qualifier C1, and the value is say test value. Okay, now let me see if it's there. I'm going to say cbt read my table. Yep, see the value is added in the table. Now this is about creating the table and putting a value into it. Now, I'll show you how to delete it. I'll take the command here. So first is I'm going to delete the table. Okay, next is I'm going to delete the instance. We created an instance, right? So I'm going to delete that. And we configured, the big table to the project and instance by creating a file. So I'm just going to create that. I'm going to delete that as well. Okay, now let's see if, so this is deleted. So let's refresh the screen and see if it's gone. Yep. Yeah, so this is about creating the instance and adding a table with adding some value in it. And then I clean it up. I deleted it. So this is just the overview of BigTable. We're going to know more about it in future sessions. However, I'll wrap it up with two sample questions. I'm going to read that to you. The CTO of your company wants to reduce the cost of running an HBase and Hadoop cluster on premises. Only one HBase application is run on the cluster. The cluster currently supports 10 terabytes of data, but it is expected to double in the next 6 months. Which of the following managed services would you recommend to replace the on-premises cluster in order to minimize migrating and operational cost? Here, the answer is BigTable. And that's because BigTable minimizes migration efforts. And it's a managed service, so it would help reduce operational costs. So here our intention is to migrate easily and also to reduce operational cost and still support, data which is more than 10 terabytes, which is going to increase. The second option, B, data flow would not be a good option, is because it data flow, it is a stream and batch processing service. It's not a data base. So we're going to stick with big tables. So the keywords here were, it's 10 terabyte of data, and you want to minimize the effort of migrating and operational cost reduction. That's the main thing. So big table is suitable for that. The next question is, you are developing a new application and will be storing semi-structured data that will only be accessed by a single key. The total volume of data will be at least 40 terabytes. What GCP database service would you use? The options are Cloud SQL, BigQuery, BigTable, and Cloud Spanner. Here the answer is BigTable because it's wide column NoSQL database that supports semi-structured data, and it works well with data sets over 1 terabyte. Now others are incorrect because they are all used for structured data. And also, option A is incorrect because Cloud SQL does not currently scale up to 40 terabyte in a single database. So yeah, so when we are given these options, Bigtable is the best option, is the best answer here. Yeah, these were the two sample questions which I found. That's it from my end. You have any questions?
Haripriya? So
Yes.
in the previous question also there was this cluster mentioned. So what were you what did you explain about cluster? I think I missed that part.
Okay. Actually, in every instance, we have clusters and nodes. That's where the data is stored. It's just subgrouped.
Okay, like in chunks or sizes.
Yeah, and chunks, yes. And um, now the clusters, when we create, we can create them in different zones, not in the same zone. So now if there is a problem with one zone, you can pick up or it's replicated. Replica is there in the second cluster.
Okay. Uh, so the replicas are the clusters will maintain replicating the data. Oh,
Yes,
yeah.
yes, yeah.
Okay. Okay.
So
Thank you.
if you have only one cluster, so it means you don't have any replication. So it's only in one zone. So if you have more than one, so you have replications in different zones.
Okay. Thank you.
That's it from my end, Tim. Thank you.